Hello, my name is Brian Pantoja Rosero, and I'm your host in these Tech Talks about digital technologies applied to civil engineering. In this episode, I want to talk about construction robotics. Where we are today, why construction companies are starting to adopt robots, why adoption is still difficult, and what I believe needs to happen for robotics to become more common in the construction industry. So for many years, robotics in construction has been presented as something futuristic. Autonomous machines building our cities, robots replacing manual labor, and fully automated construction sites. But the reality is more complex than that. Construction robotics is already here, but it is not everywhere. And it is not replacing the construction workforce overnight. We see robots on automated systems being used for tasks such as bricklaying, layout marking, drilling, painting, river tying, inspection, material transport, demolition, 3D printing, and off-site prefabrications. In some countries, robotics is also being promoted as part of broader efforts to improve productivity and reduce dependency on manual labor. So, why are developers and construction firms interested in robots? The first reason is productivity. Construction has historically struggled to improve productivity at the same pace than other industries. Projects are often delayed, costs increase, and many processes still depend heavily on manual work. Robots can help by performing repetitive tasks with greater consistency and by reducing idle time in specific operations. The second reason is labor shortage. Many countries are facing difficulties in attracting and retaining skilled construction workers. Robotics can help reduce pressure on the workforce, especially for physical demanding, repetitive, and hazardous tasks. The third reason is safety. Construction sites remain high-risk environments. If robots can take over dangerous tasks such as working at height, operating in confined spaces, transporting heavy materials, or inspecting unsafe structures, then robotics can directly contribute to safer construction practices. But if the benefits are so clear, why is adoption still limited? In my view, the biggest reason is that construction sites are not factories. A factory is controlled, repetitive, and predictable. A construction site, on the other hand, is dynamic, messy, and constantly changing. The ground condition changes, material move, more workers and machines share the same space. Weather affects the site. Drawings are updated all the time. Unexpected situations appear every day. This makes robotics much harder in construction than in manufacturing, of course. There are also economic barriers. Robots require investment, maintenance, training, and workflow redesign. For many contractors, especially small and medium-sized firms, the business case is not always obvious. If a robot only works for one task in one type of project under very specific conditions, then it might be difficult to justify the cost. There are also technical and organization barriers. Robots need reliable perception, localization, planning, and interaction with humans. they also need to be integrated with BIM, scheduling, site logistics, safety procedures, and quality control systems. Adoption is not only a technology problem, it is also a process problem. This is where I think the discussion becomes important. The future of construction robotics should not be imagined as simply replacing workers with machines. A more realistic and useful vision is robot-human collaboration. Robots can support workers by taking over dangerous or repetitive operations, while humans remain responsible for supervision, adaptation, decision-making, and problem-solving. To accelerate adoption, countries need to be doing more than isolated demonstrations. They need pilot projects on real construction sites, clear safety standards, procurement mechanisms that reward innovation, training programs for workers and engineers, and digital workflows that make sites more robot-ready. Design also matters. If we want robots to build, inspect, or maintain infrastructure, then buildings and sites should be designed with automation in mind. This means better standardization, better data, better digital twins, better coordination between design, construction, and operation. My take is that construction robotics will grow, but not equally everywhere and not for every task. The strongest adoption will happen where robotics solves a clear pain point, for example, labor shortage, safety risk, quality control, or productivity bottlenecks. In countries with high labor cost, aging workforces, a strong digital infrastructure, and supportive public policy, adoption may accelerate faster. In countries with lower labor costs or fragmented construction sectors, adoption may be slower, unless robotics becomes affordable, modular, or easy to integrate. So, the real question is not whether robots will enter construction. They already have. The real question is whether we can create the technical, economic, and institutional conditions for robotics to become useful, scalable, and trustworthy in real construction environments. And that is where engineers, researchers, contractors, developers, and policymakers all have a role to play. Because the goal is not to build construction sites without people. The goal is to build construction sites where people and intelligent machines work together to make construction safer, more productive, and more sustainable.